Hi and welcome to Cloud Core Hub. I'm excited to share today's tutorial with you on how to provision AWS Elastic Kubernetes services using Terraform. So this is a crucial skill for anyone in DevOps, Cloud or SRE roles. Let me briefly explain what AWS EKS is. EKS is a managed Kubernetes service provided by Amazon. Terraform is an infrastructure as a code tool used for building, changing, and versioning infrastructure. My goal today is to guide you through setting up an EKS cluster using Terraform. I'll be talking you through the entire process, ensuring it is easy to follow even for beginners. Please feel free to drop your questions in the comments below, and don't forget to like, share, and subscribe for more content in cloud and DevOps. Stick around to the end for some professional tips and common pitfalls to avoid. Let's dive into this exciting journey of mastering AWS EKS with Terraform. To start off Terraform on my local computer, I'll be using VS Code. So I already have a folder here called IaC code, which is infrastructure as a code for this project. So here I have to create the files that I need. The first file I will create is terraform.tf. That's the extension for Terraform Files. This terraform.tf file will contain all the providers that we need, all the information that we need for our module that we'll be deploying, which is the EKS module, and that comes with the VPC. So first here I will go to Google and search for Terraform AWS provider. Here essentially I'm looking to see like the version and just the code in general, and copy that over to my terraform.tf file. So here you see like the versions, like all the requirements, that the sample of what is in here. You can copy over the things that you need. And before you even start off this, be sure that you have set up your environment to be able to deploy AWS infrastructures from your local computer or from your local machine. So here I'll be copying this over, copy, and I'll take this over to VS Code. So here I'll move this over and zoom in a little bit so you can see what I am typing. So here I'll start with Terraform. It's just going to follow the same format from what we saw in the documentation. If you have this extension on your VS Code, it will help with auto-completing your syntax. That will be the Terraform extension. You can search that in your extension and add it if you don't already have it. So here the source is the HashiCorp/AWS, and here I'll add the version. So be very careful with the version and be sure that the version you're having or you're adding will be compatible with every other thing, your resources, the infrastructure, or like other providers that you'll be having. So apart from the tilde greater, you can also have the greater equal to, means that version and above it should support it. So here I will add the next provider, which is Random. Random is a provider. It will help with generating random IDs and strings for uniqueness in our resources. Version, here you can go over to the documentation. Here I will search for the AWS EKS Terraform module, because I want to look through the dependencies for this resource that I want to provision. go over to dependencies, and look here, we have the providers. We have the AWS Cloud Init, Kubernetes, we have Time, and we have the TLS. You see all the supporting or all the versions that these providers are supporting, these versions and greater. You can go through them and look and see what works for your environment. So AWS is the cloud service. Time, really, it helps with timing. If you're adding scheduling and timing resource in your infrastructure or in your resources, it will help when you're putting timer or like putting scheduling and timing resources. So random, what does this provider do? Random is used for generating random IDs or strings for uniqueness in our resource. So I'll copy this over and change the listing. It will be the same structure. So I already have random. Next will be I'll add I already have the random. So it will be the same. The sources are the same, which is HashiCorp AWS. So this will be HashiCorp random. And the version for this one will be tilde greater than 3.5.1. So next will be TLS. TLS is essential for creating and managing TLS certificates. Of course, it's a dependency for creating AWS EKS. We need TLS, we need certificates, we need CA certificates in our Kubernetes cluster. So this will help with that process. So next will be, time, I've explained that. It helps with scheduling. If you're adding scheduling or timing resource, the version here will be 0.10.0. Next, I will have the cloud init. So the cloud init is used for handling cloud initialization scripts. So if you have scripts that will run when you're provisioning your infrastructures, it will help in provisioning those or running those scripts in the cloud or in your cloud infrastructure. So it will initialize the script. The version will be 2.32. Yeah, I can go with this. We'll go back here and check for the other dependencies that we need. That's the next will be the Kubernetes. You see how that is. You can copy this over. It's the same thing. So Kubernetes, obviously, because we are deploying Kubernetes, so it's crucial for managing resources within our Kubernetes cluster. We are going with 2.23, 0.2. In this Terraform file, we are also going to add information for our backend configuration. So I'll go here and search for that. So you see how the structure is. I'll search for Terraform, AWS, Backend. So I'll be using S3 bucket as my backend. I will look here. You see how the structure is. Backend will be S3, then the bucket name. You write the key, or more like the path to the folder, then you add the region. So I'll copy this and come over to VS Code and paste in here. So this setup allows Terraform to store its state file in an S3 bucket, enabling features like state locking and consistency. So bucket name, I'm saying Cloud Core Hub 007. Be sure to change this if you're using the same. I'll change this to app. Be sure that you have this set up before you run this. So go to your AWS and create a bucket called Cloud Core. Oh, give it a unique name because it has to be unique globally. Key will be terraform.tf state. Region, I will stick with US East 1. We'll go over again and look through this code. And yeah, I will write the version for Terraform, required version for this. Value will be 1.63. Look over again and be sure that we are okay with all the versions and all the providers that we have added. And the structure, the formatting. Look, the next file I'll be creating here will be variables.tf. So variables is going to help with all the parameters that I know that I will use across my files or like across the module. So instead of repeating them, I can have the value here set, so I can use them, call it using the val, and call it with the value that I'll be adding here. So first will be the region. The description here will be, it can be anything. You can set it to anything you like. So the type, I'll set that to string. Then the default. So default here, if I put it as US East 1. So it means anytime I use the val.region, it's going to use this default. If not, unless if I specify the region, then it can use the region I specify. If not, it's going to use this default. I'll copy this over and duplicate because it's still going to be the same structure. So next here will be the cluster name. So cluster name, I'll be using it a lot in the module. So instead of repeating the name, I can always call it using the val function. Apart from that, if I want to change the cluster name, I can only change it in one place, which is in this variables.tf file. So it's really important to have your variables. Any information that you know will be occurring a lot in your files, you can just set them here in your variables, and you have minimum error trying to do it over. The next file I'll be creating is the main.tf file. Here I'll create main.tf. So in this file, I'll be adding the provider again, and just specifying some more information about our model here. So the provider here for the Kubernetes, pretty much the same thing, trying to define my hosts, more like our cluster endpoint here, which means we're using the EKS module to get endpoints of our Kubernetes cluster. And the host attribute will be, it will get this from the module, which I've not created. I will create this. So the module dot eks dot cluster endpoint. So it's going to get this cluster endpoint from the module that will be creating called the EKS. So next will be the cluster CA certificates. I'll be using base 64 decode. So this will decode the base 64 encoded certificate data from our EKS module, which is required for secure communication within the cluster. The source here. Oh, I made a mistake. Let me delete this. And yep. So my autocomplete did not work for this one. Let me just type it out. EKS. Cluster certificate. So it's going to get this from the EKS module. So in the EKS module, there's going to be the cluster certificate authority data in there. So it would decode using base 64 to decode the certificate authority data. Yeah, I'll delete this one more bracket. Yeah. So again, I would write provider AWS. Will be the next provider for this. AWS. And in this, I'll be writing the region. So region here, I'll be using the var function. So it will be taking the region from our region. So you see, once I did the var, there is region and there's also cluster name, because I already have that set in the variables.tf file. So next is data. That's the data source. Is going to fetch information about our AWS availability zone. This is useful for creating resources in multiple zones for high availability. Okay, here I'll do the locals, and I'll be using this in my EKS module. So to get this from cluster name, I'll call that to be var. Is going to bring up all the variables I have, which is the cluster name. Yeah, everything looks good. Next, I will create the VPC module, vpc.tf. I'll go here and check what they have for documentation for AWS VPC module. And check that out. Here, the first link, open that in a different tab. And look here, you see the module VPC, and you see all the specifications here and all the params. I'm gonna copy this and look through again and see more information here. Yeah, go to VS Code, then paste this, and modify it to what I need. Module name is VPC. The source is from Terraform AWS module VPC AWS. Go here again and check for version 552. I can here specify version in my module. That will be equal to, add that as a string, 5.52. Yep, that's okay. VPC name, I'll give it a name of my choice. You can decide what you want to name your VPC. Cloud Core EKS VPC. For CIDR, you can stick with this, or you can just make some changes. It has a wide range of CIDR blocks, or like CIDR number, IPs that it can generate from this, so you can tweak it, make it what works for you. That's fine. Name is good, CIDR is good. Here for AZ, I'm going to do something here, which would be to use the slice function to get the availability zone for me. You can stick with this and write the availability zone you have for your region, but I'm going to use the slice function here. Go through this data that was specified in our main.tf file. It will get us data, then it will get the names, and it will pull slice from 0 to 3. So it's going to take the first value, which is 0, 1, 2, 3. So it means the third one is going to exclude that, or 3 is going to exclude that, which is the fourth value. I'm going to add 20 here, 20 here, 20. Yeah, because I changed my CIDR block to add 20 here. Okay, everything looks good. Enable NAT gateway true, enable VPN gateway true. I'm going to add one more thing here, which will be I'm going to add the single NAT gateway. I'm going to set that as true. DNS host name. Something is missing. Okay, let me add the single NAT gateway. Yep, set that as true. Everything looks good. Yeah, it's meeting the S. Yep. Okay, next I'm going to check the tags. The tags are okay, but I want to modify it to what works for me. For the tags, I will put public, subnet, whatever tag that works for you is fine. But here I just want to tag some of my tag my VPCs, so I know which is for public and which is private. You can skip this process if that works for you, but this is highly recommended if you have a lot of VPCs in your infrastructure and you want to know which ones are for your Kubernetes cluster. So it's gonna have a placeholder here for local cluster name. So it's going to get my cluster name and put it in here as a tag for my public subnet. This equal to shared. Next I'll put Kubernetes.io slash row slash ELB. That will be for also saying that this will target with the ELB, that's Elastic Load Balancer, for my VPCs or my subnets. Copy this over and write this private subnet tags. Change a little bit here. For this, I'll add internal dash ELB. Oh, equals to 1. I'll set that in the public too as well. Yep, and in the private, equal to 1. Yeah, everything looks good. Next, I'll be writing the EKS Cluster Terraform module. eks-cluster.tf. I'll go over to the documentation, and yeah, I have this open. I'll check for, yep, that's the EKS. Open that up. We'll scroll down here. Nope. Go down to look at what we have for sample. Yeah, you see that there's even VPC IDs. This looks good. Let's check more things here. Yeah, we can go back up and copy this VS Code, paste. Then we can tweak from here and make some changes. There are just some things we don't need here. I'm okay with the module source version. Cluster version, cluster name, I will change this. Yeah, it's going to take local. Yep. So remember, I mentioned this in the main.tf file where it took the variable from our variables file. This version is okay. Make a space here. VPC ID. So it's going to take this from the module VPC and it's going to take the VPC ID. So once the VPC is generated or is created, it will take the VPC ID and bring it in here. ID. So subnet IDs will be next. Oh, we already have this here. Subnet IDs will be equal to module dot VPC dot private subnet underscore subnet. Cluster endpoints public access, I'll leave that as true. Then cluster add-ons, I don't need that. I already have VPCs. Yeah, I think from here I'm going to take them out, and here too out. So the EKS managed node groups. So here we are going to specify the nodes that we need. If you're going to have different node groups, which is going to be maybe the master, the worker node, and how many we need for each. So one here, I'll give a name for this group 1. I'll name that as master. So this node group will be the master node group. Instance type, I'm going to change this since it's just staging. Instance type here will be T2 medium. You can check AWS documentation and know what you need for your instance types. If this is production environment, it can go larger depending on the size of your application and the size of things you need running in your cluster. So you can check this with your software engineers. Minimum max, here I'm setting the auto scaling, so it means the minimum node will be 1 and the maximum can be 3, and the desired, that will be like the state it will be at when it starts will be 2. Copy this over, change this to 2, and this will be my worker node group, and I will have the same instance type as the worker. Go down here, I'm not sure I need the rest of these things down here. I'm gonna take them out, select, delete, then go up again, missing one more ginger bracket, add it here. Yeah, everything looks good. Yeah, this works for me. So next I'll be outputs.tf. So here are the things I will define once these infrastructures are provisioned, the outputs I need from after running the Terraform apply. So the outputs that I want is pretty simple. I want the cluster name, it will output that. I also want the cluster endpoint, I want the region, I want the security group ID as well. So I would write all this here, description. I think I'll pretty much run this fast and see. Cool, everything looks good here. So next will be to look at our backend and go create that bucket on our S3. So whatever name you give, make sure you change that, or if the name is not available globally, you can create a new name and replace that in your backend. General purpose, bucket name. Yep, leave everything as default, then create bucket. Everything looks good. We'll refresh here. Where's the refresh? Yep. Refresh and be sure everything looks good. Cool. So see here, buckets and objects are not public. Okay, cool. Everything is all set. Here I'll adjust the versions. I'll drop that a little lower, 19.19.1. Yeah, 1.27 for cluster version. Everything looks good. Oh, one more thing. I need to grab the AMI for our cluster. AMI type, you can get that from AWS documentation. Here, I would take this. That's Amazon Linux 2. That's AL2. I'll add this here. Every other thing is good. First command here will be terraform init to initialize the backend, initialize our module, and see if you run into errors with version. Remember, go back to your versioning and adjust that. Next will be to run the terraform validate command to validate our code. Validate. The response looks good. Configuration is valid. Next is Terraform plan. So this is going to show us the plan of all the infrastructure, or like the resources, the plugins, everything that Terraform is going to provision. The output from Terraform plan is going to give you the preview of the changes that you're making in your environment. So it's giving you, it's going to perform the order to transition your infrastructure to the state described in your configuration file, which is the TF files that we have written. So this will include what resources will be created, updated, or even destroyed. It will also validate your code, going to show you your Terraform code, or like feasibility of your Terraform code before applying any changes to your real infrastructure. So this really helps in catching errors or unintended changes before they are applied. So it's actually, just a read-only command that outputs the planned actions. So everything looks good. So now we'll run the Terraform apply. I'll auto approve this using this command dash auto dash approve. This will auto approve. This process is probably gonna take minutes, 10 to 20. So this is from the infrastructure or from the resources we are provisioning. I'm going to make this pretty fast, or skip to the end, but just bear in mind it's going to take minutes to provision. And while doing that, you can go to your AWS and look for all the infrastructure that is provisioning. First, EKS, we wouldn't see anything there yet, because that's gonna take some time, because the dependency of EKS is VPC, so it's going to create VPC. So you see the EKS here is still creating, and the version is 1.27 that we specified in our configuration file. So I will go to VPC now to see what is creating. VPC, and here I'll be looking for the VPC. I'll also be looking at the subnets. So this is my VPC, and the other one is the default VPC I have for my account. You see the CIDR range, you go to subnets, you see the subnets that comes with the VPCs. So we're going to have 3 private and 3 public. And Elastic IP, you look at the NAT gateway. You can look through all the infrastructure that is going to provision Some of them might not be created yet, some of them would be. Yes, we have Elastic IP created already. That comes with a VPC module. Go back to the terminal. Look, everything is still creating. I will take you to the end of it. I'm going to pause the video and come back when everything is done. Cool, everything is created. We have 59 resources added, no change, and 0 destroyed. So this is the output that we specified in our outputs.tf file. We asked for the endpoints, the name, the cluster security group ID, and the region. All this might not be necessary if you don't want them, but it's good practice to also have something to output, or you can use it as input to something else. So I'll go check out all the resources. Go to EC2 here. No, that's the load. Go to instance. Yeah, you see the instances, they come with the node group. We have the 2 worker and 2 master node. Go to the EKS now and look at our Elastic Kubernetes service. Here we'll see the node group. Yeah, we see the EKS cluster. It is active. Yep. This is it. Go to compute and see that we have 2 node group, the master and the worker, and the desired size is 2. And that will be it. I think everything looks good. Next will be to destroy. Because I'm not using it for anything, I'm just doing a demo of how to provision infrastructure with Terraform. The Terraform destroy is going to destroy everything we have provisioned with the Terraform apply. So not to worry, everything you have provisioned, you're going to destroy everything with this command. So I'll go to Terraform destroy. I can do Terraform destroy and do yes when it brings up the plan, or I can do auto approve to just delete it or to destroy everything. It's going to take almost the same time it took to create, but I skipped to the end, so you see the resources destroyed are 59. So 59, remember we had 59 resources added, now we had 57 destroyed. So I can also go back to AWS and check out. So I'll delete the Terraform file because I want to be using this in the future. I don't want all those stored. I'll also delete the state file from S3 bucket, or delete the bucket itself. Then I'll go to EC2 to check out the resources that I have running. I have nothing running because I have destroyed. If I remove this, I will see that they are all terminated. Yeah, they were created and they are destroyed, so they are all terminated here. I can check out all the resources, other resources, to see that, to be sure that everything is destroyed. So this is more like a cleanup practice, that whatever you create, you delete so you don't burn up resources. On EKS resources, nothing is here because we have destroyed it. So everything is gone now. VPC, the one we created, would be gone. Our default will still be there. Yep, you see, the default is still there. The one we created is gone. Subnets, everything is gone. This one's our default that came with the default VPC that we have on the account. S3 buckets here, I will delete it because I might likely be using the same name if I'm going to use the same code, or maybe change it. Just more cleanup. I don't need it anymore, so there's no point having it in my S3 bucket. So that's the state file. I will go delete this since I don't need it. You can also create DynamoDB to help with the state locking if you're working with other engineers, just to help with versioning and locking and making sure that your infrastructures are consistent, like everyone gets an updated info of the infrastructure you've provisioned, so they don't have duplication of infrastructures in your environment. I'll type this out. Permanently delete. This will delete. I'll go delete the bucket just to make the name available for whoever, or make it available for me again in the future. Delete bucket name. I'll copy that and paste, then delete bucket. That'll be everything is cleaned out. Next, I'll be sharing the professional tips that you need and the pitfalls to avoid when provisioning infrastructure with Terraform. Alright, thanks for watching. Bye.